All right, so for this, it's still mainly review, but looking at rational exponents, which are exponents that have fractions in them. And again, this is part of, most likely you were introduced to this in grade 10. But for this, let's kind of focus on these one at a time. So hopefully what sounds familiar is a power of 1/2 is equivalent to a square root. And vice versa, a square root is equivalent to a power of 1/2. And any radical we deal with, any square root we deal with, or cube root or something like that, any sort of root we deal with, if we want, we can write as a rational exponent. And again, any rational exponent we have, we can write with some sort of root. But it's fundamental. This is the most important building block to start with here. A power of 1/2 doesn't mean you're cutting in half, means you're finding the square root of that value. And again, this is hopefully something you saw in grade 10 where it's explained in proper detail. So what if you have a power of 1/3? Well, hopefully that sounds familiar, or you can make a guess. This is a cube root. And what if you have power of 1 over just some number? Well, whatever that a is, that's your root. So if it's a 4, it's a 4th root. If it's 7, it's a 7th root. If it's an a, it's an 8th root. Kind of hard to say. And again, vice versa. These are all true. And what if you have a power that doesn't have a 1 in the numerator? What if it's 2/3 or b over a? Well, there's two ways of writing this. I can either say this is the 8th, oh, that's a highlighter, the 8th root of x all to the power of b. That's one way of looking at it. That's perfectly fine. Or I can think of it as x to the power of b and then find the 8th root of all that. A looks like a 9. Let me fix that up a bit. Which one's better? Neither. But which one's more convenient? Well, if you want to calculate these things, quite often the first one is a little more convenient. For example, let's say I want to evaluate 16 to the power of 3/2, which is actually something that will come up in a later question, but whatever. I can think of this as this. I can think of this as the square root of 16 all to the power of 3, or I can think of this as 16 to the power of 3 and then find the square root. I will get the same answer either way, but I like this better because the first thing I would do is think, what's the square root of 16? That's just 4. And 4 to the power of 3, I can calculate pretty easily. 4 times 4 is 16, times 4 again, you get 64. So even without a calculator, you can get there rather quickly. Whereas this, good luck having this without a calculator. First you got to do 16 to the power of 3. So 16 times 16, do that, and then times that by 16 again. Get some big, big number, and then you got to find the square root of that. And so even with a calculator, this is significantly more work. So in the end, like I said, what matters is that these are both equivalent. But in terms of using these, the first one I wrote is probably, why did you run away from me? This one is probably more convenient to work with, but they're both equivalent. All right, so let's evaluate some of these. So notice of these, what do I have here? Oh, there's one more. There we go. Of these 5 expressions, they're all very similar, but they're all different, although some of them may have the same answers. But none of them are exactly the same in terms of what's written down here. So let's look at these one at a time. What does 8 to the 2/3 mean? Well, again, this is kind of what I was just talking about. I can think of this as the cube root of 8 all squared, or I can think of it as 8 squared and then find the cube root of that. They'll both be the same thing. I think it's a little bit easier to think about it the first way. So I'll do this, just make it a bit neater. Do the color coding, there we go. So the cube root of 8, what times itself 3 times equals 8? That's 2. 2 to the power of 2 is 4. All right, so with that said, I now know that 8 to the 2/3 equals 4. So if I look at the next one, I have negative 8 to the 2/3. There's no brackets here. And in fact, if you compare this to the one that's on the right side of my screen, they're very similar, but they are different. The one on the right side of the screen, there's brackets around the negative 8. That means the number negative 8 is what's being raised to the 2/3. If there are no brackets, though, it means something different. Negative 8 to the 2/3, though brackets, means 8 to the 2/3 with a negative sign in the front. Or you're subtracting 8 to the 2/3. But that makes a big difference. And again, so 8 to the 2/3, we just worked it out. It's 4. So 8 to the 2/3 equals 4. And so negative 8 to the 2/3 equals negative 4. And again, when we get to this one over here, These are, again, not the same. And such a common mistake is to misread them. And if we look at this as -8 all being raised to the 2/3, then we're reading it wrong. That's kind of, and hopefully, this is not a new idea. Everything we're doing is a review to some extent, but it's really easy to misread these things. That's it. For the next one, I have 8 to the -2/3. So what does that mean? Well, I have a negative exponent, which quite often it's helpful to write it as a positive exponent. So 8 to the -2/3 is the same as 1 over 8 to the positive 2/3. A negative exponent is equivalent to a positive exponent in the denominator. Once I do that, actually I'll highlight just the power here. Well then, I can build upon the work from the last few questions, because just this part here, 8 to the 2/3, again, we know that equals 4 already. So this must equal 1/4. Okay, so far every answer has been different. So now let's look at what I was mentioning before, -8 in brackets to the 2/3. So what does this mean? This means something a little bit different. This means the number -8, the cube root of -8, all squared. That's what it means, which again, I'm finding the cube root of -8, or the square of -8, which I wasn't in any of these previous examples. And so the cube root of -8 is -2. Right? The cube root of a negative number is possible. In this case, -2 times -2 times -2 is -8. So -2 to the power of 2. And -2 times itself is +4. So notice again, if you compare this answer, which was -4, to this one, which is +4, they mean something slightly different, so it makes sense we got a slightly different answer. And so lastly, what if we got a -8 to the -2/3? There's no brackets here. So if we look back at our previous work, this part here, you know, the power of -2/3 has nothing to do with this negative in the front. And how do I know that? Because there's no brackets. If there were brackets, then this would mean something different. And again, that's what brackets do. They change the order of what we're looking at. And if you look at what I've highlighted in pink there, 8 to the -2/3, well, I don't need to redo that, because 8 to the -2/3 is what we did right here. So I already know from the previous work that 8 to the -2/3 equals 1/4. And so -8 to the -2/3 must equal -1/4. All right, so notice all of these are a little bit different in what they mean. And so we just got to be careful when we look at these too quickly. There's a lot of little details, and literally there's little things when you have exponents because the numbers are very little. So we got to be really careful with these. That's it. Same sort of idea here. Very similar expressions here. They're all a little bit different. And so let's look at the first one. 16 over 25 to the 1/2. Again, a few ways of looking at it. The more complex these get, the more options you have. Even for questions that seem really straightforward, there's always more than one way of approaching it. I'm going to look at it like this. I'm going to take this 1/2 and write each of the numerator and the denominator to that power. So I'm going to write this as 16 to the 1/2 over 25 to the 1/2. Okay. Again, now I'm going to look at each of these, and a power of 1/2 means a square root. So I'm going to rewrite each of these as a square root of 16 over the square root of 25. And the square root of 16 is exactly 4. The square root of 25 is 5, and I'm done. 4/5. And again, there's other ways of approaching it, but I think this is fairly straightforward. And it builds upon the exponents we were reviewing the last lesson. And pretty quickly we got to that 4/5. Okay, so this time we have 16 over 25 to 3/2. So, there's a whole bunch of ways of looking at it. Just for something different this time, let me look at it like this. Let me look at it as the square root of 16 over 25. All to the power of 3. So, a power of 1/2 means a square root. The numerator of 3 is a power of 3. Now again, you may not like this. I mean, another thing you could do is immediately write all of this to the power of 3/2. And again, there's nothing wrong with that. I want to try to illustrate different ways of looking at this. That's it. The square root of 16 over 25 is not nearly as scary as it looks. It means what times itself equals 16 over 25. Or you can think, if you're not sure about that, fair enough. It means, what is the square root of 16 over the square root of 25? Same thing. That and this are equivalent. And this should look pretty familiar, because the square root of 16 over the square root of 25 we did right here. So I know what the square root of 16 over 25 is. It's 4/5. But this time it's all to the power of 3. And again, ideally, you can kind of see that right here. The square root of 16 over 25, you just think about the square root of the numerator divided by the square root of the denominator, you'll get the same thing. Either way, I now have 4/5 to the power of 3, which is the same as 4 to the power of 3 over 5 to the power of 3. And what is 4 to the power of 3? It's 4 times 4 times 4, which is 64. And 5 to the power of 3 is 5 times 5 times 5, which is 125. And now we're done. Now you are expected to know all your perfect squares up to 144. So I do expect anyone in a pre-calculus 11 class to know quickly that 9 times 9 is 81. So, and therefore know that 7 to the power of 2 is 49. Okay. However, you're also expected to know your perfect cubes to up to 125. So we should know that 1 to the power of 3 is 1, 2 to the power of 3 is 8, 3 to the power of 3 is 27, 4 to the power of 3 is 64, 5 to the power of 3 equals 125. After that, I mean, 6 to the power of 3, you could go on, it's 216. But I don't expect that we know that off the top of our head. I do expect you know these off the top of your head, which again is reasonable for a grade 11 pre-calculus class. Well, I think it's reasonable. So that's it, second last one. 16 to the negative 1/2. Well, let's compare that to the first question, which was 16 to the positive 1/2. So I don't have to start from scratch here. These are so similar. The only difference is here we had a positive power, here we have a negative power, which means I know that the answer to this is going to be the exact same as the answer to this question down here, but it's going to be the reciprocal. It goes back to one of our exponent laws we reviewed yesterday. If you have 2 over 3 to the negative 2, that's the same as 3 over 2 to the positive 2. And so in this case, if 16 to the over 25 to the 1/2 equals 4/5, then 16 over 25 to the negative 1/2 must equal 5/4, the reciprocal of that. Now that said, if you look at that and that seems like a little too quick, fair enough, then just, first probably maybe write each, the numerator and the denominator, to the power of negative 1/2, then write those without negative exponents, then square root them, and then you're done. It'll take you about 3 steps, but you should get the same answer. Again, there's lots of connections here. If you're ever looking for the way of simplifying something, you're thinking about it wrong. There's countless ways of doing it. And so lastly, here I have negative 16 over 25 to the negative 3/2. Well, it's almost the same as the second question, but there's a negative inside the brackets right here as well. So I can't just do the same thing I did with the previous one. I can't just flip over my answer from right here. So I will say, if there was no negative, and if I erase the negative inside the fraction there, inside the brackets, if it was just 16 over 25 to the negative 3/2, then the answer to this would be the reciprocal of this, 125 over 64. But it's not quite that similar. There's that negative there. So what can I do? Well, one thing I could do is still build upon things we've reviewed recently. If I have a negative power here and I don't want it, I can make it a positive power. I can change negative 3 over 2 to positive 3 over 2. If I find the reciprocal of this, and the reciprocal of negative 16 over 25 is negative 25 over 16. A reciprocal will never change the sign. You just essentially just flip it over. And now I can think about what this means. This means the square root of negative 25 over 16 all cubed. That's what this means. Well, here's where we run into a problem, because the square root of any negative number is not a real number. There is no real number that you can multiply by itself to get a negative value. Because again, the square root of negative 25 over 16 means what number times itself equals negative 25 over 16. But again, that's not possible with a real number. And so essentially, I'll say we cannot square root a negative number. Or to say it properly, It's not a real number. Someday when you're older, and if you take a lot of math classes, you may learn about imaginary numbers, which are like they sound. They're imaginary. They're not real. But then, we could evaluate this, but with, again, a number that's not real, but that's beyond this course. And so, again, I'm done. Like, really, I cannot evaluate this. The best way to answer it is to say it's not a real number. If you try this on your calculator, it will give you an error of some sort. And it all goes back to something that should not be new at all. Again, the square root of a negative number. You can't really answer it. It's not with something that's real, because again, -3 times -3 doesn't equal -9. And now we're going back to grade 7, 8. But fundamental ideas that definitely should sound familiar. All right. So with that said, that's where I'm going to stop. Again, most of these initial lessons, there's not a lot to the notes. It's more a matter of just practicing and developing, again, that eye for details.